At finehomebuilding.com, we've taken our 40 years of experience publishing an expert-written magazine for architects, designers, builders, remodelers, and do-it-yourselfers, and used it to build the best online membership available to anyone interested in high-quality, high-performance homes. With an all-access membership, you can read 40 years of FHB print issues, watch hundreds of in-depth how-to videos, follow the annual FHB house build, plan your next project with our new project guides, and much more. Visit finehomebuilding.com to sign up for All Access, the most important tool in your toolbox.
The next step in the evolution of insulating value will be a move to two triple panes. So a triple pane with 2 low E coatings and 2 gas fills will get you to an R8 glass. Mm-hmm.
Welcome to the Fine Homebuilding Pro Talk podcast, our regular discussion with building industry professionals. This is Senior Editor Mark Petersen. Today I'm joined by Jim Larsen, the Director of Technology Marketing for Cardinal Glass. You can find the Fine Homebuilding Pro Talk podcast and the original Fine Homebuilding podcast at finehomebuilding.com/podcast. You can leave feedback and ask questions there too. Good morning, Jim. Thanks for joining us.
I'm happy to be here.
Cardinal Glass, and you're coming to us from Minnesota, and that's where the headquarters for Cardinal Glass is. Can you tell us a little bit background about Cardinal Glass and your experience in the industry?
Well, this is where Cardinal started at. Today, though, we have 40-some factories around the country.
Wow.
So we cover mostly residential window manufacturers as a glass supplier to them. Everywhere around the country here. We've got about 8,000 employees across these 40 factories, companies privately held. And there's 4 main divisions that we operate under. First one would be FG for float glass. That's where we melt sand and actually produce the sheet
and float
glass.
Glass is float glass just means it's just a standard pane of glass. There's nothing coatings,
nothing added. And the name comes from the process wherein when you melt the components of glass, it literally floats on tin. And the tin is used as a separator to get that glass to float off to the end of the line to where it solidifies enough that you can transition it to rollers. And take it off on the air. So think of oil and water is kind of the way that.
So it's like a liquid bed of tin it's floating on.
Yes, it is.
Oh, interesting.
Yeah.
Okay, cool.
And so it only makes 600 some tons a day. So
that's it, huh?
Back your truck up to the factory and take a load.
Is Cardinal the biggest? It's got to be one of the biggest, I would imagine.
I think today we're certainly the biggest in the
residential.
The residential side of things. Is that we may now be the biggest manufacturer of float glass itself in the country. We're completely contained within the U.S. We don't have any manufacturing outside the borders here or anything.
Not even Canada.
No, we supply Canada. I think we're one of the larger suppliers of Canada.
Oh, okay, gotcha.
Everything is within the 48 states.
Got it.
So,
and how long have you been in the industry? And what's your background?
Well, I've been here, let's see, based on the color of my hair, probably 40 years.
Wow. Always kind of on the marketing. You have the technology chops. How does it?
I started off the first half of my career. I was the engineering manager for the insulating glass division. Okay. And in that time period that I was there, oversaw the introduction of low E coatings to the insulating glass units.
You've been around.
Yeah, I've seen a few changes. Yeah, we've seen we went through the development of adding Argon glass. Cardinal developed our own warm edge stainless steel spacer system that we use.
You're already getting right to my first question. So my first question is kind of 2 questions. In the glass industry, we've been making glass for thousands of years. But the big technology as far as the residential market goes, I mean, and commercial, I guess, too, are the two components that when you think of energy efficiency are the coatings and then the space in between the glass. So can you tell me which came first, and just quickly how did those two things come about?
Well, I think the space between the glass came first. Is that if you want to do a little bit of a history of glass performance, I could give you what I call the rule of panes. Every layer that you add into the glass panel adds about 1 point to the R value. I know the window industry doesn't do R's.
Mm-hmm.
We tend to be a little bit embarrassed about our R values compared to walls, but you can see through our R's.
Gotcha. Right.
But
you're right.
So single pane glass is an R1, double pane is R2, triple pane is R3. You might sense a pattern there. That
Does the size of the space in between the glass make a difference?
It has some impact. For air fill, the optimum gap width is about 1/2 inch.
Mm-hmm.
But you go much beyond that, and then you don't gain anything because the air starts to circulate and convect in the cavity.
So the more calm the air, the more the benefits you have.
Now, if you go narrower, if you do a 1/4 inch gap, for instance, that you've got about half the insulating value of that gap compared to that 1/2 inch space.
Did we kind of figure this out did storm windows, the idea of having 2 layers, did this kind of precipitate this where people said, hey, this works a lot better having 2 layers here?
Storm windows were sort of the beginning of at least the concept that you're going to have a multi-pane unit. So you had that single pane primary window. If you lived in Minneapolis and the outside temperature was 0 degrees, that single pane glass would be about 16 degrees. Think about how much frost you would have on that window.
Right.
It wouldn't be a window anymore. Okay. But I put a storm window on there, or I provide a double pane insulating glass unit, and that room side glass surface temperature will be in the mid 40s.
Yeah, that's a big difference, obviously.
Now you can hold 25-30% humidity in the space and not have condensation on that. So
So when did this when did it become just like a standard thing in the industry? Not so much when it was invented, but when did you start shipping out dual panes on a regular basis?
Well, Cardinal dates back to the early 1960s, so we'll call that the beginning of the insulating glass world. Insulating glass had existed for some time then, but manufacturers really started tooling up. Window manufacturers come up with the designs to accommodate the double pane insulating glass units then.
So by mid 70s, would you say the vast majority of windows being shipped were dual pane?
Yes. Actually, in the 70s, and we actually started to see some triple panes. That would think about the oil embargo from that time period, and the push for more efficiency, and some manufacturers tooled up frames that could do triple panes. But think about the triple panes, and the conflict there is that you really want to have 2 1/2 inch air spaces in that. Add in the 3 panes.
Then you're talking about So I think people do think that. They think, hey, why not just always triple pane? But it changes the whole dynamics of how the sash and the frame of the window. You can't just pull out a double pane and put in a triple pane.
Double hung, single hung, vertical slider windows are 3/4 of the U.S. market, and it's just aesthetically that deep, thick pocket and that heavy insulating glass unit are hard to work with on a vertical sliding window.
Oh, sure.
You have to balance it. You have to accommodate that thickness. All of those details there.
So the dual pane, triple pane came first. How did the coatings come up? Now, just a quick brief history on how the coatings, when they came about, and what they actually do. And what do they do? I mean, are the coatings we're putting on today the same as they were, back in whenever they came out, 80s?
Well, in the early 80s is when coatings first came out, and in the initial focus on low E coatings was to make them reflective to infrared heat, because 2/3 of the heat transfer in that airspace is by thermal radiation. And so putting a low E coating in there took that double pane R2 glass to R3, yet it's still an R2 package, still just the double pane. So that was
and so that's a low. I mean, and the coatings go by, if I'm so low E2, a low E3. Are we just talking about one coating, two coatings, three coatings?
Well, let's talk about U factor and solar heat gain before we step into that.
Sure.
From the standpoint of the window insulating value, the U factor, low E is low E is low E. I mean, there's minor differences between the coatings, but basically they're there for the low emissivity characteristics to provide the thermal resistance in the airspace. And so whether it's a single silver, double silver, triple silver, whatever, the minor changes to the U factor.
And when we're talking about radiant heat. So we're talking, does it work? Is it a two-way level? So the radiant heat that's coming in from the sun, we want to reflect that heat in the summer, obviously back away from the house. Does it work the other way too? So there's radiant heat within the house. Is it reflecting it back in?
You're talking about two different wavelengths of radiation. Thermal radiation, think of it as room temperature heat.
Mm-hmm.
Wanting to get out of the house, is a far infrared spectrum, and that's what the low E coatings are designed to reflect. Solar radiation is a high temperature. The sun is 10,000 degrees Fahrenheit.
Mm-hmm.
And the spectrum of radiation off of that is very different than the spectrum of thermal radiation that you'll get coming out of the room. So the advances in low E coatings from the single to the double to the triple silvers, as an example, are playing games with the physics of sunlight. They're still reflecting infrared heat from the room, but they're becoming selective filters on passing sunlight. So in these combinations, you can actually get solar control in a clear coating that still has the thermal characteristics that you're after. So
can you say that one more time?
Well, so let's maybe do a little bit of history here again. Is that the original coatings were high light transmission, high solar transmission, and low emittance for good thermal resistance. The subsequent variants that have come out, so let's go from a single silver to a double silver. It's still a high light transmission. It's still a low emissivity, so you've got the the heat barrier. You've got the view characteristics, but now it's kind of a medium solar transmission property out of it. It's passing the visible light, but it's not passing the infrared from the sun. That would be called.
And you would want to, I mean, obviously the variations, I'm assuming, are just from, I mean, the characteristics you want from a house in Minnesota versus to one in southern Florida. That's what we're playing with.
I would tend to think about it more as the orientation than the actual location of the building. In a northern latitude like the United States, is the southern face of a building basically sees sun in the wintertime.
Mm-hmm.
The northern face sees very little direct sun, and the east and the west, of course, get sun in the summertime. So think about what you're trying to do is that, passive solar gains can be as beneficial in Florida as they can be in Minnesota. But you're going to use something different on the south face than you are going on the north, east, or west.
I've always wondered why. And I was a home builder for a while, and we didn't do it. in a perfect world, the type of glass you have on the southern facing house, part of the house, would be different than the north. But I mean, do any builders do that, order different
No,
glass packages?
they don't do that. But that Mark would be the next step in energy efficiency in the buildings, is
Sure.
to orient the building and select the glazing characteristics to that particular orientation.
Yeah, that makes sense. And you mentioned silver. Are all, by definition, as a low E coating, is it made? Are they all made out of silver?
There are two types of coatings. There's sputtered coatings, and they're predominantly silver, and then there's pyrolytic. Pyrolytics are traditionally an indium tin oxide. They're applied on the float line on the high temperature glass. Hard coat would be the name that they're given frequently because of that tempering process of the float line. Those tend to be not as good a thermal performer as the silver-based coatings, and they don't have quite as good a optics.
So when would you see that? Where would you see that application?
Well, the pyrolytics, for instance, can be used on a storm panel. The silver-based coatings, you want to encapsulate it into airspace and keep it dry.
But silver is more, out of the two, I'm assuming silver is the more common, what you find out.
It's 95% of the market today.
Okay, sure.
And it's mostly on optics, the clarity of the coating that you can produce with that. These silver-based low-E coatings are, think of it as a sandwich. They've got an oxide on either side of the silver. The oxide is a dereflector in the visible spectrum, so it doesn't look like a mirror.
Oh, sure.
And then when we want to do the double silver, what are we doing now? A club sandwich, or a triple decker?
Right.
Okay,
sure.
So you're adding another silver on there, and you're adding another oxide overcoat to continue with the dereflection, but it then changes the solar transmission characteristics.
And these layers and silver, I'm assuming we use silver just because of it allows the visible transfer, you can see through it better.
You can see through it better. It's a relatively easy material to sputter. It goes down very uniformly, can be dereflected easily, and it just provides the best balance. There are other materials that you could use. You could use gold or other things like that, but the silver has a very good color appearance to it for a residential product.
How thin are we talking? Are these layers?
You can't see it. You can see through it. Okay.
Right.
These coatings are 1,000 angstroms thick, and what's a human hair is 10,000 angstroms.
So 10 times thinner than a human.
You're putting discrete metal layers down on the glass that are thin enough that you can see through them.
So then back to my original question, E1 or low E, low E2, low E3. Again, are we just talking about that's how many layers they are, and
it's how many layers of silver, and that's changing the spectral selectivity. So I think the easiest way here, Mark, to describe it is that think of it as a high solar gain low E, a medium solar gain low E, or a low solar gain low E.
Okay,
they're all generically clear. Okay, there's a little color to the coatings, but they're high light transmission products that are not reflective. They don't look like mirrors.
Let's move on from coatings and talk about the space between. So you always hear argon filled glass.
Yep.
Is there a reason why? I mean, what about argon makes it good? And then I've noticed that krypton is another option. Why do we use argon, and what makes krypton better, and why don't we use that all the time?
Well, argon or krypton, both of them are noble gases. They don't degrade. They don't break down in sunlight or anything like that. So you don't have to be worried about them decomposing or anything along that line. Argon is about 30% lower conductivity than air. So that's why you use it in that airspace is to reduce the conducted heat transfer. Argon is about 1% of the air.
So in the ambient air right now, there's 1% argon.
1% argon. There's
Gotcha.
78% nitrogen, 21% oxygen, 1% argon, and then little tiny parts of other things like krypton.
So
krypton
yes.
is 1/1,000,000th of the air.
Ooh. And I'm assuming there's a process to remove everything else but the argon, which is probably easier than removing everything else but the krypton.
For every 1,000 parts of argon, you get 1 part of krypton.
Gotcha.
Where do you think the price of krypton is relative to argon?
Sure, that makes sense. And
about
Cardinal
1,000.
doesn't. I mean, Cardinal doesn't get into that process. I'm assuming you just somebody. I mean, you don't process.
No, all of these gases come from the distillation of air, primarily for liquid oxygen. For steel furnaces, we use liquid oxygen in our glass plants to melt sand. Processing gases, nitrogen is used as a cover gas for a lot of welding operations.
So the gas, it's not that much different than a refinery, oil refinery,
right?
That, refines diesel, kerosene, whatever, gasoline.
You want that high grade stuff? You're going to pay more for it.
Right, gotcha. And so, what makes krypton more high grade? What qualities is it? When would you want to use it?
Well, krypton is another. I think it's about 20% lower conductivity than argon. So it has.
Gotcha.
That's where the advantage would be, but the one downside that's not realized too much on krypton is that it's a slippery little bugger. If you put a big temperature differential across a cavity of krypton, you'll start to get convection circulation. It'll start to flow and move around inside of that cavity. So
does it need the cavities need to be smaller?
They need to be smaller. The optimum gap width for krypton is about 1/4 inch.
What percent of windows are you shipping out that has argon versus krypton? Is it 90?
Well, everything that we do with low E today is argon filled.
Okay.
Krypton is a fraction of 1%.
Okay, gotcha. And when would you use it?
You would use it for thin triples.
Okay.
So where that optimum gap width is, around 1/4 inch, you can do 2 skinny air spaces and make this thin triple that fits into a standard double pane pocket in a window frame.
What contributes to the comfort level inside of a room more, the space or the coatings, or is it kind of a thing where they just work well together?
Well, I think it's getting them all to work together. So for comfort, there's 2 things you want to look at. One would be the U factor. The lower the U factor, the warmer the glass will be on a cold winter night, and the more comfortable you'll be in those wintertime conditions. The other one is the solar heat gain coefficient, because that's a measure of the solar gain coming into the space. A lower solar gain is going to have less sunlight coming in and less risk of overheat of the space, and big fluctuations in the room temperature then.
Yeah. Okay. So that makes sense. So it kind of depends on what the conditions are outside. Yep. The space that separates the glass, is it true that the first glass that was formed that had 2 panes, it kind of was all one unit and the outside edge were kind of welded together, I guess?
Well, if you go back to the original patent on insulating glass, which was like 1860, they used a rope with a wax seal as the way to make the edge seal.
And we don't do that anymore. So what do we do? What do we do now? What do we use for spacers now? Is there one spacer that's better than another?
No, there's every kind of material out there, and lots of different sealant systems. The question always comes down to the durability of the design. and I would recommend to your listeners here is that look to the warranty. Check the
Sure.
manufacturer's warranty as the first indication of confidence that people have in the product and the long-term durability.
I know we have, and people who've been in business long enough, they know that we had some issues. I don't know if it was the early 90s, late 80s, with those seals breaking and you get the fogginess between the glass. What was going, was it kind of one thing that caused? Because I think it was industry wide pretty much.
Oh,
Was
I
there
thought
one type?
the insulating glass industries had a couple of instances of that, occur through there. In the 60s, one of the first problems came about for rapid reformulations of the sealants because most of them at that point in time were solvent based. And the EPA started coming down on the use of solvents and everything there to that they did quick reformulations on the materials,
Sure.
and they didn't have the durability that one had hoped.
Just didn't have enough time to test them
Yeah.
to see how. Yeah. Okay. Well, that makes sense. I've never heard that.
I think the one thing to look at on the whole durability question on a glass failure is that if you have a failure in the first 2, 3, 4 years, that's most likely a workmanship issue. That's a void. That's a void in the seal. It's some lack of completion of that seal. Then beyond that, if you start getting seal failures, that's a durability issue.
Okay.
So call those early ones infant mortality. Maybe
Okay. That's kind of dark, but we can do
yeah.
that. What about the type of window these these panes are going into? Is there a difference in your mind whether it goes into a wood window or a aluminum window or a fiberglass or vinyl window? Is there? I mean, does one type of window material make the glass last longer than another?
No, I think it's more a function of the glazing system itself. What are the sealants that are used to glaze the window in? What's support on the bottom of the glass? We like to see setting blocks underneath that unit to allow water to drain out of the way. You don't want to have the unit sitting in a pocket of water and have that water seeping into the sealants and softening them up. So it's
So the
just
sealants are water. I mean, they're water. I mean, I assume that there's some type of silicone system,
well,
or not.
there's silicones, there's hot melt butyls, uh,
Mhm.
polysulfides, polyurethanes, a variety of different materials, but they can all be water sensitive. If you soak
Okay.
them in water and then expose them to high temperature and flexure as the wind is blowing on them and everything like that, it can soften the sealants and cause extreme movement there and just weaken the system.
When you work with a window company, I mean, you're one of the biggest glass manufacturers in the country, if not the biggest. Do you work with let's say let's say the startup vinyl window company? They want to design a window. Would you have certain parameters saying, "Hey, this is the way in order to, not void your warranty, we really need you to install these windows in the sash in a certain way," or they just do whatever they want and then and then come
So
to you later and say,
there's some standard glazing recommendations. We get back to uh, the Ghana recommendations at the Glass Association of North America that
Mhm.
there's some guidelines that most of them will follow that.
"Gotcha." Have you had cases where window manufacturers come to you and said, "Hey, why is your glass not performing?" And you say, "Well, this is why you didn't put these
Yeah,
blocks
so
in or whatever."
and there's been instances. There's been, you want to talk about the workmanship issues that in the past there's been wood window manufacturers, as an example, that do a solvent treat to the wood,
Hmm.
for wood preservative. Well, if they don't let that dry, if that solvent volatilize out, then the unit is sitting in all those vapors. As that is drying out, that can cause softening of the seals.
Interesting. So I'm
Yeah,
assuming today's window unit that goes in a house is compared to one that was going, let's say, in the early '80s, is just a vast improvement.
we learn from our past history.
Right? What about noise reduction? If somebody wants noise reduction, where's the biggest bang for the buck? Is it adding an extra layer of glass? Is it adding a lamination? What would, if you lived in a busy city street and you wanted quieter windows, and money was a consideration, what would you do to make a quieter window?
Well, all things being equal, the laminated glass would be the biggest bang for the buck. Okay.
Okay, so not a triple
Laminated.
pane. I guess that's
Yeah.
surprising. I guess I always thought it would be an extra pane.
Those two panes of glass, and then, well, I would think an insulating glass unit that incorporates laminated. So you've got a cover pane of regular glass over a laminated panel as part of your
So laminated panel, we're talking like safety glass,
like the windshield of your car. It's two
Sure.
layers of glass that are bonded together with the plastic inner layer. Polyvinyl butyral.
So technically, that is 3 layers of glass, because you have, but there's no space. There's only space between the two.
Yeah, technically it is 3 panes of glass. Thermally, it's 2 panes of glass. When they're bonded together like that, the thickness of the glass doesn't really impact the insulating value at all.
Okay.
But laminated glass has the unique characteristics to it that the interlayer material dampens sound. So you see that on high-end cars as an example. They use laminated glass not only in the windshield, but on the side lights and the backlight for sound reduction. Then
Well, and it adds safety too, I would imagine.
But it adds safety. Well, there are 2 types of safety glass, right? You've got tempered and you've got laminated.
What do you think about? I just talked to a builder recently, and he said that, he was talking about, you need tempered glass in certain parts of the house, in a bathroom, or if the window's 18 inches or whatever, close to the ground, or in stairwells where somebody could fall. And he said he doesn't use that. He uses he just uses an aftermarket kind of a coating that he puts on the exterior or the interior of the glass. What do you think about those? Is that void? I would imagine that can't be good for your warranty, or does it hurt anything?
Let's not even talk about the warranty. Is that he owns it? Okay,
right.
He's producing that himself then. Whereas the Safety Glazing Certification Council is testing regularly all people that manufacture under that banner. So when we do laminated glass or tempered glass and put the SGCC sticker on that glass, we're part of that program. There's quality control that you have to follow through on, regular testing that you have to follow through on, and aftermarket films. This sounds like some magic wax or something like that that you put on your car. That I'm maybe saying it that way. Particular is that I don't think they have the durability and the likelihood of lasting the time period that you would expect.
Sure.
A windshield in your car or a window in your building.
Yeah.
So if that's his business position, I can appreciate him wanting to do that. For the cost of tempered glass, for the cost of laminated, it sounds like a huge risk that he's taking.
Right. Yeah, that makes sense. And and like you said, you don't know how that thing's if it's on the sunniest side of the house, is it going to turn gray or cloudy in 2 years? Right. Well, unfortunately, there's a lot of builders, and to be honest, I think this builder was taking a shortcut, because the only time he would do it is if he would get caught by the inspector for not having tempered glass where he was supposed to.
And I was just going to say is that I'm not sure how he got his local code official to recognize that.
That's a good question. That's a good question. All right, technology. So the Windows today, much better than they were. What's the next great thing that's coming down the pike? What do you see? I mean, what do you see in 20 years from now where that's not even going into a window today that's going to be standard on a window 20 years from now?
Well, I think the next step in the evolution of insulating value will be a move to 2 triple panes. So a triple pane with 2 low E coatings and 2 gas fills will get you to an R8 glass.
Mm.
So it's going to, it's going to be a 50% reduction in the heat transfer compared to the glass that we're doing commonly today.
But when we spoke earlier, I mean that's going to increase the sash size.
Well, that
And
means
the,
you have to
and the
you have to design a window to accommodate
right.
that glass. Unfortunately, today we're working around, dare I say, turn of the century window designs. And
Yeah.
I'm not talking the 21st century. I'm talking the yeah.
Right.
Okay. I mean,
Yeah.
and great windows out there and everything like that, but everything's been kind of built up around the double pane mentality, and you can do triple panes well with
Mhm.
with better designs there. That I think the push for more efficiency will push those window designs in.
How about mistakes? What do you see in? I mean, what are builders or even window manufacturers, for that matter? What are the most common mistakes people are making or misunderstandings that people have about glass? Maybe it's the one that we mentioned earlier about putting the same glass in every side of the wall. But what other mistakes do you see that you wish you could tell everybody that, hey, stop doing that?
Well, I think it's comes down to one, the glazing design. How this window holds the glass up. Does it provide proper support? Does it provide water drainage? Are there pinch points in the frame that can impact the glass and have questions to the durability on that? And then go ahead.
Good. So let's say a builder's shopping for windows, and is there a way to, I mean, besides looking for the sticker that says Cardinal Glass, is there a way? Is there a way to? I mean, any shopping advice for a builder building a house who wants to have one of the best quality windows
He wants quality.
no
Yeah,
callbacks.
yeah.
They don't want any callbacks. What are we looking for?
I'd say first thing is that look to what the manufacturer is offering for the warranty.
Hmm?
We talked about that before. You got to have confidence in your product. Now you could be blowing smoke
Right.
with that warranty, but generally somebody that's been around a while and offers a long-term warranty has had to live through their past mistakes and learn from those experiences and provide better products then.
Right. And if they've been in business for a long time, that's probably a good sign that they've learned more mistakes, learned from their mistake, more of them in the past. Well, I think that's a good place to end. Unfortunately, that's all the time we have left today. I want to thank you, Jim, for joining us. I really appreciate that. And thanks to all of you for listening. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And please like, comment, or review us wherever you're listening. It helps other folks to find our podcast. Stay safe, everybody, and thanks again for listening.